So here I'm going to label W with the subscript A, referring to the metal A, and this is the weight. And the question really is, do I know this ratio for this alloy K? So I'll start with statement 1. So in alloy K, the ratio becomes 5 to 6 when 40 pounds of metal A is added to the alloy. So if you're starting with WA and WB, if you add 40 pounds of that, which means our A quantity is that, and our ratio is 5 to 6. So you'll see that this will, if we cross multiply, you're not going to be able to get a ratio from this. You get this equation. We're not able to get a unique value for that, meaning if you divided each term by WB, another way to look at it, that ratio is going to depend on how much alloy and the weight of the metal B is. So we don't have a unique value. 1 is insufficient. 2 says the ratio of metal A to metal B in alloy K becomes 7 to 6 when 60 pounds of metal A is added. So we have a similar setup. Numbers are different. And that's 7 to 6. So again, we'll not be able to get a unique value for the ratio, as you can see. So 2 alone is insufficient. If you combine 1 and 2, we really have 2 equations, 2 unknowns, and we can find WA, then we can find WB, and so it would be sufficient that way. But if you need to do the algebra, we can just divide these 2 equations. You'll notice the WB's drop out, and this becomes 5 over 7 because the 6 part is common. And then we can cross multiply, and this would really be helpful only in cases where it's a quant reasoning question and you have to do this algebra. But numbers should turn out to be nice. WA is 10, and then we can figure out WB by plugging into one of these equations. Let's say if I do that here, it'll be 50 over WB, 5/6, and that's WB will become 60, and now we can answer that question. That ratio is 1/6. So all this work is optional once you recognize that these are 2 independent equations, and you will get a unique value for that ratio. So the answer is C.